Welcome back to The Explainer. I want you to picture something for a second. A perfect, crisp blue sky. You look up, and miles above the Earth, there's a commercial airliner silently cruising along. From all the way down here, it looks completely peaceful, right? But trailing right behind it is this massive, bright white streak stretching across the horizon, literally cutting the sky in half. It's a sight we've all seen hundreds, if not thousands of times. But how often do we actually stop to think about what's really happening up there? Today, we're going to break down the incredible atmospheric science behind this everyday phenomenon. It's Vapor on the Void, a documentary guide to contrails. Okay, let's dive right into this. It's honestly one of the most common questions people have when they just spend a minute looking up. Why exactly do airplanes leave these bright white trails in the sky? Like, what is actually coming out of the back of those massive aircraft? Is it smoke? Some sort of chemical emission? Well, to really understand this, we've got to look past the common misconceptions and look directly at the beautiful, raw physics happening miles above our heads. It's a purely scientific process, and as we go through this explainer, you're going to see exactly how a massive flying machine interacts with the invisible layers of our atmosphere. First things first, let's get our terminology right. The proper scientific name for these white streaks is a contrail, and that word is simply a mashup. It's short for condensation trail. Now, that word condensation is absolutely crucial. It's the key to solving this whole mystery. It tells us right out of the gate that we're not looking at smoke from a fire, but actually a phase change of water. You know the condensation that forms on the outside of an ice-cold glass of water on a hot summer day? Well, contrails are exactly that. They're the direct result of water vapor transforming under very specific extreme environmental conditions. Part 1. Inside the jet engine. So to understand how that condensation happens so high up, we have to go right inside the roaring heart of the aircraft. Inside that jet engine, fuel is burning at incredibly high temperatures to generate the immense thrust needed to keep a multi-ton aircraft airborne. The byproduct of that intense combustion? Exhaust. But here's the thing, jet engine exhaust isn't just dry heat. As the engine burns fuel, it's constantly ejecting hot, highly moist exhaust and gases right out the back. A massive component of that exhaust is pure water vapor. So picture this. You've got this intense, concentrated stream of incredibly hot, wet gas being blasted out of the turbine at hundreds of miles per hour. Part 2. The freezing upper atmosphere. All right, so we have our first ingredient, hot, moist exhaust. But to actually get a condensation trail, that exhaust needs an environment to react with. When commercial jets reach their cruising altitudes, which is usually between 30 and 40,000 feet, the atmospheric air outside is brutally, dangerously cold. We are talking far below the freezing threshold of 0. Up there, the air is thin, and the temperatures are so extreme that any moisture present is desperately trying to freeze into solid ice. This extreme, freezing void is essentially the canvas that our jet engine is about to paint on. Part 3. Birth of an ice crystal. This sets the stage for one of the most traumatic, yet entirely invisible collisions in nature. The fiery, wet heat of the engine exhaust is about to violently slam into the deep freeze of the upper atmosphere. Let's walk through this rapid-fire sequence. Step 1. The hot, moist exhaust aggressively leaves the jet engine. Step 2. That superheated exhaust instantly mixes with the extremely cold sub-zero atmospheric air. And step 3, this violent temperature crash forces the invisible water vapor in the exhaust to condense instantly. But it doesn't just turn into liquid water. No, it's so incredibly cold up there that it bypasses that completely and freezes solid into tiny ice crystals. The water vapor is literally shocked into a frozen state in a fraction of a second. And this brilliantly illustrates the grand scale of what we actually see from the ground. Look, a single ice crystal is microscopic, right? It's completely invisible to the naked eye. But remember the sheer volume of exhaust a commercial jet engine pumps out every single second. We aren't just talking about one crystal, we're talking about millions, billions of tiny ice crystals forming continuously, side by side, in the direct wake of the aircraft. When sunlight hits this massive, dense cluster of freshly formed ice crystals, it reflects back to our eyes on the ground as a solid, brilliant, visible white trail. You are quite literally looking at a man-made glacier of microcrystals suspended in the sky. Part 4. Fading versus persistent contrails. Now, if you're a keen observer of the sky, you've probably noticed that not all contrails act the exact same way. Some vanish almost as quickly as they form, while others stretch from horizon to horizon, lingering for hours. So why the difference? Well, the fate of an ice crystal in the upper atmosphere is dictated by a few invisible but absolutely crucial atmospheric variables. The two biggest players here are atmospheric humidity and freezing temperatures. While the temperature up there is pretty much always freezing enough to initially form the crystals, it's the ambient humidity, meaning the amount of water vapor already naturally present in that specific layer of the atmosphere, that dictates the ultimate lifespan of the contrail. Now, what's really interesting here is how clearly we can juxtapose the two outcomes based on those exact variables. Check out the short-lived contrails. If the surrounding atmospheric air at that altitude is very dry, the newly formed ice crystals will rapidly undergo a process called sublimation. That's a fancy way of saying they turn directly from solid ice back into an invisible gas. So the trail disappears quickly. But then look at the persistent contrails. If the upper atmosphere is already highly humid and saturated with moisture, the ice crystals just don't evaporate. Instead, they remain in the sky, trapped in a frozen state, lingering for a very long time. And when conditions are right for those persistent contrails, the physics get even more fascinating. Because they're lingering in this humid environment, high-altitude winds begin to catch these ice crystals. They pull them, stretch them, and push them all across the sky. The contrail literally starts spreading into thin, wispy, cloud-like formations. These are essentially artificial cirrus clouds. Depending on the specific humidity and temperature that day, a single plane can create a persistent contrail that spreads out to cover a massive portion of the sky, completely transforming the visual landscape above us for hours. I want to leave you with this exact takeaway today, because it just perfectly summarizes the amazing science we just covered. So the next time you see a white line behind an airplane, you're seeing tiny ice crystals formed by water vapor in the cold upper atmosphere. It's not smoke, it's not pollution, it is the majestic, rapid-fire physics of water changing its state in the absolute extremes of our planet's atmosphere, made totally visible by the sheer power of aviation. Which leaves us with a truly fascinating thought to ponder. If something as routine as a commercial flight can interact with the invisible variables of humidity and sub-zero temperatures to literally paint massive, lingering trails of ice across the sky, what other invisible atmospheric secrets, shifting currents, and microclimates are unfolding right above our heads every single day, completely unseen? You know, the sky is so much more than just an empty void. It's a dynamic, complex, and deeply fascinating laboratory. Keep looking up, keep asking questions, and we'll see you on the next explainer.